In this session, we shall be looking at the derivatives of natural logarithmic functions. So, natural logarithm refers to a logarithm of a number with the base of e. So, when you have a logarithm of any number to the base of e, then we can say that such function is a logarithmic function, and it is written in the form of, so we have the logarithm of x, where x is a number and then e is the base that we are talking about, and this is the same as what? Ln x. So we'll be looking at derivatives of functions of this nature, or derivatives of functions in terms of natural log. Now, to find the derivative of a natural logarithmic functions, we differentiate the inside function and then we divide it by the inside function. So given any natural logarithmic function such as y is equal to ln of any function of x, then we can say that its derivative, which is given as y prime of x, is equal to the derivative of the inside function all over the inside function, or u prime over u, where u is the inside function. So what we are going to do is that when the function is in terms of ln of any function of x, we differentiate the inside function. So this is the inside function of x. We differentiate it, then we divide it by the same inside function. So we are going to take examples and then see how best we can apply this. Given the function y is equal to ln x, we have to find the derivative of this very function here. So we can see that this is a natural logarithmic function, ln x. So the derivative is saying that we differentiate the inside function all over the inside function. So we are going to identify our inside function. So here we can say that our inside function is what? X. I believe you can see that this is our inside function. So we are going to let u be equal to the inside function, which is what? X. And then after that, we differentiate the inside function, which is what? X. So we are going to get u prime, which is s. Now when we differentiate x, we are getting what? 1. I believe you remember. Okay. So if that is the case, then we are going to write our derivative, which is written as y prime of x, is u prime all over u. And we know that our u prime is 1 all over u, which is what? X. And this is the derivative of the natural logarithm function ln x. You see how simple it is? Very, very simple. We take more examples. So if y is equal to ln of x squared, find the derivative of this very function. So you know that these are logarithmic functions. We are going to apply this formula u prime over u. So we identify our u function. So we let u is equal to what? S squared. This is the inside function, which is what? S squared. Then after that, we find u prime. So u prime, this is u. So when we differentiate u, we are getting what? 2x. Then we know that our derivative of a logarithmic function is given as u prime all over u. So our u prime is 2x all over u, which is what? X squared. So from here, we can just do a little simplification. X will cancel one of the x, applying the laws of indices. When the bases are the same, we subtract 1. So we are going to get 2 all over x, and this is the derivative. So we have example 3. If y is equal to this function, ln of x squared plus 4, we have to find the derivative of this function. So what we are going to do is we just identify our inside function. So we say that we let u is equal to x squared plus 4. Then we are also find the derivative of u. So when we differentiate x squared, we are getting 2x, and whenever we differentiate a constant, we are getting 0. So we can say that our derivative y prime of s is giving us u prime all over u, and our u prime is what? 2x all over u, which is what? S squared plus 4. This becomes the derivative of the function here. Very simple. So to find the derivative of this very function, example 4, we apply the same concept. So we identify our u and then we differentiate u. So we can say that our u from here is the inside function, which is equal to 3x power 5 plus 2x power 3 plus 4. This is our u function. We therefore find our u prime, that is the derivative of this function. So when we differentiate 3x power 5 using the power rule, we are going to get 15x power 4. Then plus, using the power rule, we have 6x squared. And then whenever we differentiate a constant, we are getting 0. Now having this, we know that our dy dx, which is the derivative, is giving us u prime all over u of a natural logarithmic function. So our u prime is 15x power 4 plus 6x squared all over u, and our u is the whole of this. So we have 3x power 5 plus 2x power 3, 2x power 3, and this becomes the derivative of the function. You see how simple it is. You differentiate the inside all over inside of any logarithmic function. Now let's see how we can blend the chain rule, the product rule, quotient rule, and then the rest with the natural logarithmic function. So we are going to start with blending it with the chain rule. So we take an example on. So we have the function ln of x raised to the power 7. We have to find the derivative. So you can see that we have a power of 7 and we have ln x. This should tell you that we are having an outside function which is power 7 and an inside function which is what? Ln x. So this, we have to apply the chain rule. This is similar to having, let's say, x plus 4x raised to the power 7, x plus 2x raised to the power 2. So we can apply the chain rule for this. And we know that in applying the chain rule, we say that the derivative y prime of x for chain rule, we differentiate the outside function. So we know that the outside function is giving us f prime of g of x, I believe you remember. Then multiplied by the derivative of the inside function, which is what? G at x. So what it means is that we are going to differentiate the outside function and then we differentiate the inside function, then we multiply. That is what? The chain rule. I believe you have not forgotten. If you have forgotten, go back and then watch the video. Now, so we are going to find our f of g of x, then we find the derivative. So we know that our outside function is power 7. So we are going to get ln of x power 7. Are you with me? And then we find our g at x. So we know that our g at x is the inside function, and the inside function is what? Ln x. Okay, now what we are going to do next is we have f prime at g at x and then g prime at x. So we differentiate each of them. So we have f prime at g at x. So when we differentiate this, applying the power rule, we are going to get 7 out ln of x, then subtract 1 from the exponent, giving us 6. And then the g prime at x will be equal to, now this is a logarithmic function, we differentiate the inside all over inside, so u prime over u. So the inside is what? X. So let me write it this way. U prime all over U. Are you with me? So we can say that our G prime of X is giving us U is what? X. So when you differentiate X, we are getting 1 all over U, which is what? X. So let's continue here. So we know that our Y prime of X is giving us this F prime of G at X. So where is F prime at G at X? We have this. So we have 7 ln X all raised to the power 6, then multiplied by the derivative of G prime at X, and that is for 1 over X. So we have 1 all over X. Are you with me? So you can say that our derivative Y prime of X is going to be 7 ln X power 6 times 1. We are getting the same thing, 7 ln X power 6 all over X, and this becomes the derivative of this very function. It's very simple, very simple. So we have another example. We have to find the derivative of this function, cube root of ln X. But remember, this cube root can be written as 1 over 3. So let's rewrite this function to be in the form of ln X raised to the power 1 over 3. Are you with me? So you can see that we have an inside function and then an outside function. So we can apply the chain rule, which says that we differentiate the outside multiplied by the derivative of the inside. So we are going to let our f, like how we did this one here. So we know that we let our f at G at X be equal to what? Ln of X raised to the power 1 over 3. Are you with me? And then we let our G prime at X be equal to the inside function, which is what? Ln X. Good. Now we find the derivative of each of them. So we have f prime at G at X, which is equal to, now when we differentiate using the power rule, we have 1 over 3 ln of X, and then we subtract 1 from the exponent. So we are going to get minus 2 over 3. Is that okay? And then we find the derivative of J prime at X, which is what? Ln X. And we have solved this several times. We know that ln X from here is giving us what? 1 over X. So we have 1 over X. Good. Now you just have to substitute these functions and their derivative into this formula, the chain rule formula. So you know that the chain rule formula is giving us Y prime of X is equal to F prime at G at X, which is the outside function, multiplied by the derivative of the inside function. Good. So you know that F prime at X is giving us what? 1 over 3 ln X raised to the power negative 2 over 3, and then multiplied by the derivative of G prime at X, which is what? 1 over X. Good. Now the next thing we have to do is just simplify, just simplification. So 1 times this, we are going to get ln X all raised to the power negative 2 over 3 all over 3 times X will give us what? 3x. You can leave your answer in this form, but it's not nice. So let's further simplify it. We are going to get 1 all over 3x. Now you know that this can also be written in the form of ln x raised to the power 2 over 3. I believe you have not forgotten. So this is the derivative of this very function.